Hi, this is 9.3. This is actually part 2, and these are the first set of problems in this section. And we were doing two things. We're going to find the first four terms, and then we're going to find the common ratio. And again, you can find the common ratio by listing the terms down and dividing any two consecutive terms, or you could identify the ratio by looking at the base. But you got to be careful sometimes when you're trying to find the base. So let's find the first four terms of this example: a sub 1, a sub 2, a sub 3, a sub 4. This is the easy part because all you're doing is just plugging in 1, 2, 3, and 4 into the formula. So you plug in 1, 3 to the first is 3, 3 to the second is 9, 3 to the third is 27, 27, and 3 to the fourth is 81. Now, if you want to find the common ratio, then you can divide the second term by the first term. So it would be 9 divided by 3, which is 3. But like I said in the previous part, all you got to do is look at the base because it's exponential in form and the ratio is the base. So if you don't notice this one, the base is indeed 3. So the ratio is 3. So you didn't really need to do the second divided by the first if you can identify the base. The problem is the base is not always easy identifiable. And you're going to see it, especially in example 3. If you just glance at example 3 up there, the c to the n equals 2 to the 3n. When I get there, I'm going to let you know up front, the base is not 2. So it looks like the base is 2, but it's not. So I'll let that one stay there for a little bit longer. Let's look at example 2. So example 2, b to the b sub 1, b sub 2, b sub 3, b sub 4. So you plug in 1, so it'd be negative 1/3 to the first, which is negative 1/3, so it'd be negative 2/3. Now plug in 2, so 2, so it'd be negative 1/3 to the second, which is positive 1/9, and then 1/9 times 2 is 2/9. And then you plug in 3, so it'd be negative 1/3 to the third, which is negative 1/27, and then times 2 is a negative 2/27. And I think the next one is going to be a positive 2 over 81 if you do the math. Now, as you could probably see, example 1, the base was easy identifiable just because 9 divided by 3 or even 27 divided by 9, they're all 3s. You can't really do that so easily just by looking at the quotients. You would actually have to do a little bit of math. And if you did that, the ratio is the second term but divided by the first term. Well, the second term is 2/9, and the first term is negative 2/3. So if you invert and multiply, it's 2/9 times negative 3 over 2. Take the reciprocal and multiply. And that becomes negative 6 over 18, which reduces down to negative 1/3. So the ratio, the common ratio is negative 1/3. But if you look at the original problem, b sub n equals 2 times negative 1/3 to the n, notice there is a negative 1/3 in the problem. It's right there because that's the base. The 2 is not part of the base. It's actually a vertical stretch. So that's not part of the base. It's just negative 1/3. So like I said, if you can identify the base, you don't really need to do the second term by the first term. So the only problem here, some people would have chose the base to be negative 2/3, which is not. So it's just what that is. It's what's underneath the n. What's underneath the n is the base. So, and that's going to help. Now that statement right there, what's underneath the n, is going to help me with example 3, because when you look at example 3, what's underneath the n is not just 2. So let's do some here. Oh, by the way, the a sub n, b sub n, c sub n, d sub n, just different sequences. They don't always have to be a sub n's. Just like functions don't always have to be f of x. They can be called g of x, h of x, j of x. Doesn't always have to be f of x. So same thing here. So c sub 1, c sub 2, c sub 3, and c sub 4. So plug 1 in. So you plug 1 in, you get 2 raised to the 3 times 1, so it's 8. Now you plug in 2, so it'll be 2 to the 6, because 3 times 2 is 6. And then 2 to the 6 is going to be 64. And then you plug in 3, so it'd be 2 to the 9th. And I think that's 512. And then plug 4 in, be 2 to the 12th. And then 2 to the 12th. Oh boy, let's see. I think if I'm correct, it's 4096. So 2 to the 12th is 4,096. Yeah, I think that's correct. So now, again, you can find the common ratio by dividing the second term by the first term. And you see, here's your gut feeling. Your gut feeling thinks it should be 2 because you see a 2 down there. But let me show you something before I actually do it the long way. I said a while ago it's what's underneath the end. So this is what's underneath the end. So it's actually 2 to the 3rd, which is 8 to the end. So these are really the same thing. 2 to the 3 is the same thing as 8 to the 1 end. I mean, these are the same thing. And if I gave the problem to you this way, everybody would say, oh, it's 8, because that's the base. But most people would say base is 2, even though these are the same thing. So, the common ratio should be 8, because that's what the true base is, even though it says 2 down here. But it's what's underneath the end. And a 3 is part of that. So 2 to the 3rd, which is 8. Now, you don't want to remember any of that junk. You just say, well, just do the division. So R is equals to the second term divided by the first term. So the second term by the first term would be 64 divided by 8. And then 64 divided by 8 is 8, which is that. And by the way, I just glanced over their example 2. I just noticed something. And some of you guys probably noticed it as soon as I wrote it down. B sub 2 divided by B sub 1. I'm using the B function, not the A function. So anyway, so this is example 3, and that is how you find the common ratio. So these are 2 things we're doing, finding the first 4 terms of the common ratio. Now, example 4 is probably the toughest one of them all. So we do D sub 1, D sub 2, D sub 3, and D sub 4. The D sub 1 is going to be plugging in 1. So you plug in 1 to the top, that's 3. Plug in 1 to the bottom, that's 1 minus 1, which is 0. So 2 to the 0 is 1. So it's 3. And then find the second term by plugging in 2. 3 to the second is 9. And then plug 2 in the bottom. 2 minus 1 is 1. And then 2 to the first is 2, so it's 9 halves. And then the third term, plug in 3. 3 to the third is 27. And then plug in 3 in the bottom. That's 3 minus 1 is 2, so that's 4 on the bottom. And then the fourth term, plug in 4. 3 to the fourth is 81. And then plug in 4 on the bottom is going to be, let's see, 3 be 8. 81 over 8. Now, first I'll show you how to find the common ratio the hard way. And that's just dividing the second term by the first term. So it's going to be 9 halves divided by 3. Invert and multiply, it's 9 halves times 1/3. And I believe that's 3 halves. Okay? But I could have told you it was 3 halves before I started. Because the top number, what's underneath the end, is 3. What's underneath this end is 2. Even though there's a minus 1 there, that's not part of it. It's not like this one's 2 to the 3 end. What's underneath the end is just the 2. So 3 is underneath this end, and 2 is underneath this end. So it's 3 on top, 2 on the bottom, 3 halves. So, but that's kind of the hard way of doing it there, is actually doing that long division, because you got to take the reciprocal and multiply. So, but these are 4 examples, and that should definitely get you through that first set of problems in 9.3. So the next part is part 3 coming up.